All right, here we are with section 5.7, the fundamental theorem of algebra. And what the fundamental theorem of algebra does is it helps us to find the zeros that are in functions, or at least determine how many zeros there might be. One of the key concepts here is the terminology repeated zeros. That means if I were to graph like a parabola and it comes down and it barely touches and it goes back up, not a very good looking parabola. Right here we would have two zeros, and that might be x minus 2 quantity squared. Might look something like that, where right here 2 is one of my zeros, but there's two of them at that one place. And so that's a concept of repeated zeros. When I look at the fundamental theorem of algebra, one of the concepts is that if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers, meaning in the set of regular numbers and complex numbers, all real numbers plus complex ones, there's at least one real zero there. And if I take a look at the corollary, if it's a degree n, then there's exactly n solutions. If it's repeated twice, there'll be 2 solutions. If it's repeated 3 times, there's 3 solutions. A graph that might have 3 things repeated kind of looks like this. It goes through and then it buzzes right through here, and that ends up having 3 right there in one spot. So let's take a look at example 1 here, and it'll go by kind of quick. How many, since this is a 3 degree, right, third degree, 3 degree, how about third degree? How about it's a third degree polynomial, then it's going to have 3 solutions. And since this is a 4th degree polynomial, it's going to have 4 solutions. That only makes sense. And so this one, checkpoint 1, take a guess. What do you think? Did you say 3? If you did, you'd be right. Third degree polynomial has 3 solutions. Now, this next example has given me trouble for a long time. In fact, this is the second time I'm taping this. I can't believe I fell into this again. There is an error in your book. Make sure you turn this minus 9x cubed into plus 9x cubed. Now, what's crazy is somehow I figured out that that was the error. Instead of just saying bad question, we went through and we found it one day. Right here, since it's a 5th degree polynomial, I'm going to have 5 zeros. I'm going to try to find those 5 zeros. So one of the ways to find them is you find all the possible rational zeros with this 12. You take the constant at the end and the leading coefficient, which in this case is 1, and all the factors of 12 divided by all the factors of 1. Well, 1 only has 1 factor, so that makes it kind of easy. And you have positive negative 12, positive negative 6, positive negative 4, positive negative 3, positive negative 2, positive negative 1. These are all my possible solutions. So there's 1, 2, 3, 4, 5, 6. There's times 2. There's 12 different things that could be a solution. You could determine through synthetic division, if you divided everything out, that 2 is a 0 repeated twice. And you could also determine that negative 1 is a 0. Now, I don't expect anybody to actually do synthetic division and all that. That's a ton of work. And the much easier route to go is to go down here to your calculator, turn it on, type into your Y menu, and you might take a minute, x to the 5th minus 5x to the 4th minus, right there is supposed to be plus, isn't it? That's where it messed me up last time. Plus 9x to the 3rd minus 5x squared. And if you graph it, the picture that you'll see, let's all get on the same window here. Let's do a zoom standard, so we can all see the same thing. And as I graphed that, what I found was, you see that repeated 0 right there that I talked about? This right here is a repeated 0 at 2. And so that's that 2 that's repeated twice. And you see this right here is a negative 1. And remember, you can go in and calculate zeros and it'll find those for you. But I know that some of the factors of this thing are going to be 2 2, and negative 1. So my factors end up being x minus 2, quantity squared, x plus 1 to the first power. And then if I did all the dividing stuff that we learned about in the last section, you would end up finding 2 other zeros that are not on the graph because they are imaginary. And those 2 other zeros that you would find would be x, and one of them was minus 1 plus I square roots of 2, 1 plus I square roots of 2. Sorry for that handwriting. And for every one of those, because it has to have its conjugate, you're going to find x x minus 1 minus I square roots of 2. And so under all of those things, you would just divide those out. When you divided these 2 out of it, that's what you'd have for an answer. So let me get this calculator out of our way real quick. And so you'll have those for an answer. What happens is you find this 2 and you find this 1. Maybe you use synthetic division or whatever. When you got down to it, you'd have this left. And so if I use synthetic division, I might do something like this. If I put a 2 into the 1, negative 5, 9, positive 9, negative 5, negative 8, and 12. If I put a 2 in there, I got 1, 2, negative 3, negative 6. Remember synthetic division from the last section. 3, 6, 1, 2, negative 6, negative 12. Well, remember my 0 for my remainder, so I'm good. Then I start all over again with another 2. So I do the same thing. 1, 2, negative 1, negative 2, 1, 1, 2. Okay, 1 times 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 2, 3, 1. 2 times 1 is 2. 2 plus 1 is 3. Found a mistake. 2 times 3 is 6. Knew this had to equal 0 because it was one of my factors. And then my other factor that I found, using my calculator, was that negative 1. So I drop that 1, get a negative 1 here. Add them together, negative 2, 2, 3, negative 3, 0. And so after those first two factors were divided out, I found this other piece by factoring x squared, 1x squared, you see that, minus 2x plus 3. Okay? And if I use the quadratic formula on that right there, on this part right here, you'll find these two answers right there. And it's x minus, just like we talked about before. So as you work through that stuff, it can get pretty tough. Very, very high level thinking skills here. Just do your best to work through there and see what you get. Hopefully on this one here, on number 2, you found negative 1, 4, 2 plus I, and 2 minus I. Hopefully that's one of the answers that you found. Let's take a look at this next page here. The complex conjugates theorem. Okay. The complex conjugates theorem says if f is a polynomial function with real coefficients and a plus bi is an imaginary 0, a plus bi is an imaginary 0, then a minus bi is also a 0. So if you ever get one of your zeros being imaginary, you got to have the opposite to it. And this is leading into them giving you some questions that have that. So a rational conjugates theorem says, suppose f is a polynomial function with rational
There's a
coefficients.
student first name Abraham in the building. Please come to the switchboard.
How's that make you feel like a student again? You got an announcement right in the middle, make you feel like you're right back at school, not sitting in the cushy couch somewhere watching your iPod right now. A plus the square root of b is a 0 of f, then a minus the square root of b is a 0. They have to go together. So if you get one, automatically get another. It makes sense when we do the quadratic formula that it's always a plus or minus, right, something. So that makes sense. Let's go on to example 3 here. This will be the last thing we do is just example 3, and we're not going to get into Descartes' rule at all. So it says write a polynomial function. This is on the test. There's a question just like this. Write a polynomial function f of least degree that has real coefficients, a leading coefficient of 1. So that means in the end I'm going to have just something x to the whatever power. So my leading coefficient is going to be x to the whatever power. That's an important thing to know. Okay? And -2 is one of the zeros. That means x minus -2 is going to be one of my zeros. 3 plus I is another one of the zeros. 3 plus I is another one of the zeros. Now, if 3 plus I is one of the zeros, 3 minus I must be the other zero. Okay, because they go together. If you have a 3 plus I, you got to have a 3 minus I. On the test, make sure you got it. So I have x plus 2. And then right here, I'm going to take my negative and go whoop, whoop. And it becomes x minus 3 minus I. And this becomes x minus 3 plus I. Now, you have to expand this whole thing. I'm going to work on this part first. So I'm going to multiply x times x. And I'm going to put my x plus 2 over here just so I don't forget about it. X times x, I'm going to get x squared. X minus 3, I'm going to get minus 3x. X times positive I get plus xi. Then I'll multiply -3 by everything. Minus 3x plus 9. See, I'm multiplying this -3 by everything over here. Minus 3i. And then I'll multiply -i by everything. -i times x is minus xi. -i times -3 is plus 3i. And -i times positive I is -i squared. And so let's see what just happened to all that stuff. I'm going to change colors here so you guys can see this. I'm going to use red to mark some things out. So I have -3x right here, -3x right here. First of all, I have an x squared that doesn't go with anything. So I'm going to put my x squared on this line right here. So I have it. -3x, -3x, -3x. That's a minus 9x, as far as I can tell. So I'm going to just put a little slash through those. Oh, wait. There was only 2 of them, wasn't there? All right. How do I get my eraser back out here? I only had 2 of them. See that? 3x, minus 3x, minus 3x. So I'm going to make that 6x. All right. I have a plus xi and a minus xi. They're going to cross each other out. I have a minus 3i and a plus 3i. They're going to cross each other out. And that x squared is now gone. I have a 9 minus I squared. Well, I squared, remember, is -1. So it's minus -1 or plus 1. 9 plus 1 is 10. Plus 10. All right. Work through that whole thing. Woo! And we're going to multiply that by x plus 2. So I have this whole mess in front of me. Now I have to multiply this x right here by every one of these things. So let's change colors one more time. Let's go with green this time. So I'm going to take that x and multiply it here, and I'm going to put it right here. X cubed minus 6x squared plus 10x. Then I'm going to take my 2 and multiply it by everything, plus 2x squared minus 12x plus 20. And wouldn't you know it, I got my answer. 6x squared plus 2x squared minus 4x squared. By the way, this was a 3. Should have been a 3 because I had 3 zeros, right? Minus 2x plus 20. Now, if you take that, put it into your calculator, it better come up with negative 2 as a 0. And that would help you to see if it's right. Let's go ahead and you do the checkpoint down there and see how you do. All right, so how'd you do? Write a polynomial of least degree that has a 1, a 4, and a 1 plus the square root of 6. Well, hopefully you started out with x minus 1, x minus 4, and x minus 1 plus the square root of 6. And this little part has parentheses around it. The one piece that they didn't give me, that they should have gave me, is an x minus 1 minus the square root of 6 with parentheses around it. Remember, you're going to have to eventually take that negative and go whoop, whoop through there. Now, your answer, your final answer should be, if you do all your FOILing correctly, x to the third minus 6x squared plus 3x plus 20. If you do everything right, that's what you should get. We'll talk about that tomorrow. Thanks, folks.